The James Webb Space Telescope has uncovered something truly remarkable: beams of light that appear to radiate from a city center, shining from a location light-years away. This discovery has revived interest in the potential existence of extraterrestrial life. The focus of the telescope was set towards Proxima Centauri b, the nearest exoplanet to our solar system, and it detected strange, brilliant flashes of light. Could these signals be signs of an alien civilization? Keep an eye out for more developments. For years, both scientists and the general public have been captivated by the concept of life beyond Earth. Any indication of the presence of life in outer space has been met with great enthusiasm. However, a pivotal moment occurred when the James Webb Space Telescope presented clear evidence suggesting the existence of life somewhere in the cosmos. While scanning the depths of space, this powerful telescope discovered something extraordinary on an exoplanet. Because it was so far away, it detected lights that resembled those from extraterrestrial cities, igniting the possibility that an alien metropolis might exist on a distant planet. This idea has generated significant excitement and curiosity within the scientific community, as it could be the long-awaited breakthrough. It hints at the presence of intelligent beings operating civilizations in ways we are only beginning to explore. Observing these lights, resembling those of a large city, at a distance of 4 light-years away has astonished NASA engineers. They now wonder how long these lights might have been visible in space, awaiting our technology to advance to the point where we could finally detect them. David Kipping, an astronomer at Columbia University, has described the planet where these lights were discovered as particularly unusual. Unlike most rocky planets, it intricately absorbs sunlight and emits energy as infrared radiation. This exoplanet behaves differently due to its unique relationship with its host star, Proxima Centauri. This discovery made by the James Webb Space Telescope underscores the telescope's critical role. Its ability to capture infrared wavelengths was essential in identifying the unusual behavior of Proxima Centauri b, which is crucial for understanding the planet's atmospheric conditions. Researchers plan to continue using the telescope to study the atmosphere of this planet in greater detail, hoping to investigate whether it might be habitable. The James Webb Space Telescope is particularly sensitive to infrared light, enabling it to observe what occurs even during the nighttime on Proxima Centauri b. Many telescopes struggle to discern faint light in the vast void of space, but the Webb telescope excels at picking up even the faintest glimmers. This makes it an ideal tool to confirm whether the alleged city lights on the dark side of Proxima b are, in fact, real. The telescope can detect artificial light in space, provided it falls within a very specific frequency range, much narrower than the light emitted by regular stars. Proxima Centauri b has a dynamic interaction with its star, which heavily influences its environment. Like many planets that orbit stars, it captures intense energy from Proxima Centauri. As the planet revolves around the star, it goes through cycles of day and night, much like Earth. The planet experiences scorching heat during the day and cooler temperatures at night. The range of temperatures on Proxima Centauri b is vast, primarily due to its composition. For example, if the planet has an atmosphere, the difference in temperature between day and night would be extreme, blazing hot on one side and frigid on the other. This dramatic thermal fluctuation is a key area of interest for astronomers, as it provides useful hints about Proxima Centauri b's atmospheric makeup. The James Webb Space Telescope, with its ability to image in the infrared spectrum, can effectively examine the planet's thermal emissions, offering insights into its atmospheric properties. Interestingly, the orbit of the James Webb Space Telescope around Earth coincides with the orbital period of Proxima Centauri b, enabling scientists to make detailed observations of its day and night cycle. If this cycle occurs every 11.2 Earth days, and Proxima Centauri b has an atmosphere, the next step will be to analyze its chemical composition to determine if it could support life. Detecting elements like oxygen, water vapor, and methane would imply that the planet has the potential to harbor life. This would involve studying the light passing through the planet's atmosphere, a difficult procedure. While the James Webb Space Telescope is excellent for characterizing planetary atmospheres, it is primarily designed for other tasks. Its expertise lies in analyzing concentrations of water vapor, carbon dioxide, and methane, but it is less adept at detecting free oxygen, a crucial sign of life. Nonetheless, the telescope can search for other key indicators like ozone, which signals a healthy atmosphere. As scientists examine the data gathered from the James Webb Space Telescope, the hunt for distant worlds continues. The search is bringing us ever closer to answering the question of whether we are alone in the universe. It's important to note that the James Webb Space Telescope can only observe a limited number of exoplanets closest to Earth. For more detailed studies of planetary atmospheres, astronomers will rely on ground-based observatories like the Extremely Large Telescope (ELT), which is set to begin operations in 2027. The ELT is designed to offer a deeper look at the atmospheric structures of far-off exoplanets, providing clearer and more detailed data on their potential to support life. Scientists are eagerly awaiting the launch of future space telescopes like the ELT. In the meantime, the James Webb Space Telescope remains an invaluable tool for exploring distant exoplanets. Despite its limitations, the Webb Telescope continues to offer important information that could alter our understanding of what exists beyond our solar system. Researchers have ambitious plans for future space telescopes. They aim to develop technologies that reduce starlight interference, allowing for better observation of planets around them. Similar to using your hand to block the sun so that you can see more clearly, these upcoming telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres and assess whether they might be capable of supporting life. However, this task is far from simple. Stars are incredibly bright, often vastly outshining their surrounding planets. This brightness makes it difficult to detect the planet's faint light reflection, which is essential for studying their qualities. To deal with this challenge, scientists are working on several innovative techniques. One such method involves the use of coronagraphs. These devices are placed inside telescopes to block out starlight while letting the light from the planet pass through. By carefully shaping the light waves, coronagraphs can significantly reduce the brightness from the star, making it easier to detect the dim light. Another promising discovery in exoplanet research is the starshade, a massive flying spacecraft shaped like a flower. In formation with a telescope positioned tens of thousands of kilometers away, the starshade blocks starlight before it even enters the telescope, allowing only the light from exoplanets to reach the instruments. This technique could be particularly useful for observing planets within the habitable zone of their stars, where liquid water and possibly life could exist. However, these modern technologies necessitate extraordinary precision. For instance, the alignment of a starshade must be perfect to millimeter-level precision over extensive distances. These innovations must also overcome the limitations posed by space missions, including the need for miniature energy efficiency and the ability to withstand the harsh space environment. Despite these obstacles, the potential rewards are enormous. Successfully observing and evaluating the environments of exoplanets could lead to the discovery of biosignatures, chemical indicators of life, such as oxygen, methane, or water vapor in specific ratios. These molecules might point to biological processes, suggesting that life exists beyond Earth. Researchers are also exploring ways to directly image distant worlds in greater detail. Future telescopes may be outfitted with advanced adaptive optics that correct distortions caused by Earth's atmosphere or the telescope's movements, resulting in sharper images. Combined with starlight blocking technologies, these improvements could allow scientists not only to detect exoplanets but also to map their surfaces and study their climates. The development of next-generation space telescopes represents a significant leap forward in our quest to answer one of humanity's most profound questions. Are we alone in the universe? By increasing our capacity for observing these distant planets, we are getting closer to finding out if life exists beyond Earth, potentially transforming our understanding of our place in the cosmos. Furthermore, the search for life beyond Earth is advancing at an unprecedented pace. As scientists and astronomers dive deeper into the mysteries of distant exoplanets, the James Webb Space Telescope is ushering in a new era of cosmic discovery. The data it gathers assists astronomers in groundbreaking revelations about the structure, composition, and potential habitability of far-off worlds. With each new piece of information, we edge closer to answering the ultimate question: is there life beyond our planet? What follows from this discovery is just the beginning. Proxima Centauri b being the closest exoplanet to our solar system, has been a focus of intense research for years. However, until now, finding concrete evidence of life, such as artificial light or signs of civilization, was only a dream for many scientists. The fact that such light has been detected by the Webb telescope only enhances the hope that one day we may contact other intelligent life forms in the universe. This kind of discovery fuels both scientific curiosity and public imagination, inspiring new generations to think beyond the confines of Earth. As the James Webb Space Telescope continues its observations, it is not only looking for artificial lights but also analyzing planets' atmospheres, their chemical compositions, and how these factors could support life. The search for biosignatures like methane or carbon dioxide in the right concentrations is vital for understanding whether these planets have the ideal conditions for life. The telescope has the ability to study these atmospheric components in ways no previous telescope has, shedding light on the potential of distant worlds to support life similar to Earth. One of the most fascinating aspects of Proxima Centauri b is its location within the habitable zone of its star, where conditions might be right for liquid water to exist on its surface. The habitable zone is the region around a star where temperatures are just right, not too hot and not too cold, for liquid water to form. This is considered a critical factor in determining whether a planet could harbor life. Since water is essential for life as we know it, the discovery of an exoplanet inside a star's habitable zone makes it a key target for future missions. In addition to finding life-supporting planets, future space telescopes will also focus on the complex relationship between exoplanets and their stars. Some planets, like Proxima Centauri b, are tidally locked, meaning one side always faces the star while the other side remains in darkness. This can create extreme temperature differences between the two sides of the planet, affecting its climate and potential to support life. Understanding these conditions is critical for astronomers as they assess the likelihood of habitable environments on exoplanets. The development of technologies that can block out the bright light from stars is another major step forward in space exploration. Without the ability to block starlight, it would be virtually impossible to observe the faint glimmers of light from distant planets. The coronagraph and starshade technologies mentioned earlier are prime examples of how scientists are overcoming these challenges. By blocking out the overwhelming brightness of a star, these tools enable telescopes to detect the faint light reflected by planets, revealing crucial details about their surfaces, climates, and potential for life. Another exciting development in this field is the concept of direct imaging of exoplanets. With the help of starlight blocking technologies and advanced adaptive optics, astronomers hope to capture high-resolution images of planets as they orbit their stars. These images would not only provide comprehensive data on planetary composition and atmospheres but could also reveal surface features such as oceans, continents, or weather patterns. This type of imaging would represent a giant leap in our ability to study exoplanets and make informed conclusions about their potential to support life. As we continue to explore the universe and search for answers about the existence of life beyond Earth, the role of the James Webb Space Telescope and future missions will be indispensable. The telescope's ability to detect faint signals from distant planets, analyze their atmospheres, and examine their potential for habitability is transforming our understanding of the cosmos. With advancements in technology and an ever-growing body of research, we are on the brink of making discoveries that could reshape our knowledge of life in the universe.